Loving King of Glory, thank you for this day. Thank you for the gift of life and salvation and all you've done for us. King of Glory, as we're going for this lesson, we pray that we'll understand everything and that your spirit will be with us. Let there be a good connection. In Jesus' name I've prayed. Amen.
Amen. Thank you, Faith. Good afternoon, girls. I hope so far so good since you started your morning classes. Faith, you can raise your hand. Thank you. Yeah, we finished our topic last week, and on Friday, I remember telling you that we are going to post some work on the Google platform, which I expected people to do. She was opened at 2 p.m. on Friday, and it closed on Monday, which is yesterday, at 6 p.m. So it's unfortunate that some of us don't want to do work on time. You wait for the last minute, and that's when you want to do the work. There were 40 questions, and we expected you to get time within, those days to sit down and you do the work. So if you didn't hand in, it's unfortunate. Life cannot be like that. Whenever you have a task at hand, always try to do it within the required time, and the earlier the better. So I want to congratulate the 206 girls. I know somehow we might be having a few cases of intruders, because some people were entering using funny emails. I don't know if in this class we have someone with an email delivery guy. I saw someone with an email of delivery guy, and I'm not sure if that is our student. And then the other challenge I saw, the instructions were very clear. Put your name as it appears on the class list. And then someone goes ahead and see her putting only one name, Ruth, and they're going to do the work. So how do we identify which Ruth is which? Okay, so let us always follow the instructions. If the assignment is telling you to enter using both names, it's because we want to capture your details for recording purposes. Okay, so I have the records of the 206 girls who were able to submit. Okay, if you didn't submit on time, sorry. That work was posted on the Google Classroom. You can go there and pick it, but that means you have not sat for the test and we don't have your mark. Okay, yeah, so I want to throw it back to you. I want you guys to share the experience, because we seem to be having challenges as far as answering some of those questions are concerned. So today's session, you want to look at the assignment we gave you and any other questions that you could be having, because we are supposed to start another topic, which is about statistics. Okay, Joseph, any other thing you want to add on before the girls come in?
Maybe to stress the point of emails. I request the girls to get their own accounts, because someone was saying that she failed to edit, and I think she has something like Teen Nation, something like that. So I request the girls to generate their own emails, and then if they generate them, we can always add them. And then the other thing was maybe some girls have no Google Chrome, because they fail to open the link or the test because it opens in Google Chrome. So they need as well to download it on their devices. And then to stress the point that you said of doing the tests in time, because some of them had a rush hour towards the end, and then the internet failed, so they couldn't submit on time. Yeah, that's all I had. Thank you.
Thank you, Joseph. I see someone's hand is already up. Can we hear from Hope? Hope? Hope, Eunice?
Teacher, you asked us to tell you about our experiences in the test.
Yes.
All I can say that I was able to learn new things, like some things I hadn't understood before, I understood them better in the test. Yeah. And I learned basic principles on how to find certain things. Yeah.
Okay, thank you. We deliberately gave you this test, which was covering all the topics, most of the topics that you've covered since you joined S1, because we wanted to make a reminder. I don't want people to focus more on the current topics they are doing. Always go back and try to remind yourself of the concepts that you've covered before. Yeah, on the issue of emails, the school is trying to see if we can, for your safety, we are going to generate school-based emails, okay? So for example,
maybe you can first
okay.
handle that. Okay, maybe
But
as teacher Theo
it's
is
there.
Yes.
It's there. Okay.
Okay.
So do we have any of the girls to help us understand what they did? Maybe before the teachers come in.
Okay, let's hear from Esther Lucy.
Okay, so the question is, for a senior one party organizers both 7 and 2/3 crates of soda for each girl to share a bottle. If each crate contains 24 bottles, how many girls are in senior one? So this means that they first served out the crates of soda, they first served out 7, but there remained some girls who didn't get the sodas. So they got another crate and started serving out, but they only served out 2/3 of that crate. So they've told us that one crate has 24 bottles. So we first find the number of bottles in the 7 crates, which will be 7 times 24. First, which will be 7 times 24, and we get 168 bottles. So then we go to the 2/3. The 2/3 of the crate that has 24 bottles. 3 divided by 24, we get 8. So that will be 2 times 8, which gives us 16. So we are going to add the 168 plus 16, which will give us 184 bottles. So if each girl got a bottle and the bottles served out for 184, that means that the girls were 184.
Okay.
Okay. Yes, Joseph.
Thank you very much. Teacher, you can proceed.
I'm trying to handle a case here. There is someone who is Nampera Anisha attacking me.
Yes,
I don't know
okay, thank you.
Yeah, you can be handling that as I get out of the class.
Okay. Okay. As well, I had issues with her, but as you're sorting that, yes, it is very right.
Okay. I guess we can proceed. Yeah, I've ejected that person. Yeah, girls, once again, let us not share our login details with our friends in other schools because we keep getting these issues, okay? So someone is busy attacking me in my chat and I don't want to speak the words that person, has sent me, but it's unfortunate that we keep sharing our login details and we get intruders who keep disturbing us in classes. So can we stop that if we are doing it? Okay. Yeah, but soon we are going to get a solution for that. Okay. Yes, Joseph, can we move on?
All right. She was right. What you need to do is change that mixed fraction into an improper fraction. Okay, because if a girl is to get a bottle, then you have to buy a number that will accommodate your class. So just convert that fraction to an improper fraction, then multiply times 24. Because each crate is having 24 bottles, then you'll be having your answer as 184.
Okay.
Thank you.
Joseph.
Yes, please.
This was the fraction given, 7 2/3, not so?
Yes.
So when you are converting, you're going to get 7 times 3, okay, plus 2. I hope the girls know how to do that. You get the whole number times the number which is in the denominator, and then you add the number in the numerator. And this is 21 plus 2, which is 23 out of 3. So this can be another way of doing it on top of what your friend has just told you. So we are having this fraction representing the number of students in class, but they have told you that each crate has 24 bottles. So ideally, every student, I guess, will get a bottle, right? So if one crate has 24 bottles, it would imply that 24 students are going to take a crate, okay? That is what as we try to go through this, I'm seeing a poll running. You can quickly tell us which class. Okay. They wanted you to find out how many students are represented by this fraction of 23 out of 3. So you will say that the number of students going to be equal to 23 out of 3 times the number of bottles that are in the crate, technically, which is the number of students that can consume a crate. I don't know if that takes us to the same answer, Joseph. Takes us to 184. Okay, when you simplify it. So this can be another way of doing it on top of what your friend told you, of first getting how many students are consuming 7 crates, and then you get the number of students that are equivalent to 2/3. Joseph, I see hands. Can you try to attend to them?
Okay, let's hear from our default. Please unmute.
I wanted to ask if you can do that number of 8 to power 2, then I don't remember exactly, but it was something like 8 to power 2, then 3 to power 2.
Okay.
I'm supposed to find was it common multiple? I really don't know.
Yes, maybe teacher Theo can run very fast to that.
What's the question?
There's a question where they ask you to find the least common multiple given variables of A and B.
Oh, okay.
Yes.
guess that's the number. Okay, we are given a squared and a cubed b, and they wanted us to find the LCM. LCM is the lowest common. Okay, they want you to get the lowest common multiple. So what you're seeing, those numbers are not different from, I mean, the expressions you're seeing are not different from when you are given numbers. Okay. So I have a squared, then a. Okay. So if you are to use that, you can still do the division. What is, maybe let me throw it back to the girls. Someone who did it to help us understand it.
Okay. Let's hear from Yvonne. Yvonne.
Teacher, I think, okay, like you get a squared divided by a and you get a.
So you are saying what is common here is a squared. So when you get a squared divided by a squared, what do you get? 1, eh? So you put 1 here.
Yes.
When
Then
you get 8 power 3
cube b
divided by
divided by
a squared,
squared,
you get
you get a b. I think you get a b.
you get a b.
I think you get a b. Yes.
Is an a that is to power 3. So you only reduce that 3 to a 2 and you remain with 1 a. Okay. 8 power
Yes.
3. 8 power 3 is the same as a times a times a. You do it 3 times, eh? And if you are dividing a squared, the same as a times a. So you can see that these two a's are going to cancel and you remain with 1 a. Okay?
Yes.
But b. So it implies that here you're going to get a b. Okay?
Then you divide by a.
You divide by a, it remains.
You get 1 b.
Then you
Then you divide by b.
Get 1 1.
Get 1 1.
So what would
you
be
get
that in this
a
case?
squared times a times b, which will give you a cube b.
Times b, which is 8 power 3 times b. So I don't know if it helps those who are wondering how they get that answer. The LCM was supposed to be that a cubed times b. Joseph?
Yes, please.
Is teacher Martha in class? We seem to have forgotten about Martha. Martha, can you talk to us?
It's okay, I'm following through.
Oh my God, sorry.
It's okay.
Yeah, you can try to get in once in a while. I think it's because Joseph the quiz, so that's why I keep getting back to him. Yeah, but you can weigh in once in a while. Eh?
Teacher Steve.
Yes, please.
We have as well teacher Jennifer, though she has network issues, but she's as well following. Then we have another burning question. I think because it is coming through in my chat, where you're having a rectangular board. It is saying a rectangular board is 108 centimeters wide and 156 centimeters long. Where they ask you to find the size of the square. Yes, I don't know whether anyone tried it out before we give up you.
Okay.
Someone, let's hear from Shaggy.
Teacher, Can you see the question again? I didn't hear so clearly.
Okay, the question was saying, have you reached there, Mr. Theo?
Joseph, yeah,
Yes.
let me paste it here. I've copied it from the, let me paste it there. Is it visible?
Okay.
Okay. Yes, teacher.
Yes.
Okay, let me try it out. So you first draw a rectangle.
A rectangle, yes.
Yes. And then you label 1 8 centimeters width here on the width side. 108 width, yes.
Okay, 108.
And then 156 centimeters on the length.
Okay.
So for me, what I did is I first looked for a square number that is next to 156. And the square number was 144 centimeters cube. So when you get that, you draw a small square inside here. Yes, there. So you realize that 12 will be the side, one side of like a small square. It will be 12 centimeters here, like a small square. Yes. So when you multiply 12 times 12, you get the size of the square.
Okay.
Yes.
Saying 12 times 12 here?
Yes. So you come this side and say 12 times 12 centimeters equals 144, right? 144 centimeters squared.
So that's how you arrived at the answer. You didn't make use of 108. You used 156 to arrive at that.
No, I used both.
No, but you told us you looked for a square number, which was
yes, yes. Now you look for a square equal. Okay, first look for a square number here.
Did you pick 156 because it's the biggest?
No. Okay, let me show you how I did it. So I first get the number here that was one down here, right down the length. Sorry? I wrote there that it's 144. Then
yeah.
It is yes, down there. First right down there. 144. So you realize that number it has its square as 12, right? So you also come this side on the length. And then there, here I got 12 after right, some little division. 12.
12, like this?
Yes, 12.
But what would be the easiest way of doing it?
This way.
Okay. Maybe we can get another view. Yes, Joseph.
I don't know whether these girls do recall what we discussed under highest common factor and then But before we give our view, let's hear from Nyende, Daniela.
Teacher, me what I did, I found a GCF of 156 and 108, and I got 12 as the side of a square. Then I multiplied 12 by 12 and I got 144 centimeters squared as the size of the square.
Thank you. That is the best.
Okay, Joseph, go on. Joseph?
Yes, please.
You go on.
I was saying the girls should note that there are application questions for such concepts, okay? But what you should always note is a statement determining whether the concept you want to obtain is is larger or minimum or small, okay? If it is large or highest, then you're talking about highest common factor. If it is lowest, that is lowest common factor application, lowest common multiple applications, okay? If you run through the guide, I think those are the questions we discussed last concerning highest common factor and then lowest common multiple. So those are the application questions. So you find a number of them, but you need to identify those words, which help you identify which concept you to apply easily. Thank you.
Okay, Joseph, thank you. Maybe to help them generate the values that we need to get the largest possible square. What they're asking you to do is you're having 156 and you're having 108. And these two values have some common factors. Now, of those common factors, there is one which is bigger, okay? And you realize that if that value is common to 156 and 108, then one side is going to have that value, and then the other side is also going to have that value because it's common to both, okay? So it's basically, they basically want you to do some kind of finding the highest common factor amongst the two numbers. And that is what is going to form the sides of the square. Now, if I may go through this quickly, usually when you are doing these numbers, it's easier if you start with the lowest prime factor. In this case, it's 2. So when you divide 108 by 2, you have 54. And then 156 by 2 gives you what? Joseph, can we pick the girls?
Yes,
maybe in the interest
okay.
of time, we can move quickly.
Okay, let's have Charity. Charity?
I was asking that same question, that why do we make the GCF? Why do you take the GCF as the side of the square?
Okay, just because we are looking for a number which is common for the two sides, okay? Common for the width and common for the length. Hope you get the point now.
And that number has to be the big.
So you were breaking, I can't hear you.
Okay, I said we use size common factor because we want to identify that common number for the two sides. That is for the width and then for the length. Okay.
Okay.
Am I clear? I don't know.
I
Yes,
see.
thank you, teacher.
I see hands up. Maybe you can first pick some before we continue.
Okay, let's hear from Melissa.
Teacher, I was asking about the previous number, the one with the AB. If they asked for the highest common factor instead of the lowest, then what would the working be?
If they asked for what?
If they asked for the highest common factor instead of the LCM.
If they asked for the highest factor, usually they are talking about factors which are common, but out of those factors, there is one which is the biggest of all the factors. So in this case, they wanted us to find the biggest square. Okay, a square has equal sides. So they wanted us to, it's like if you can be having a room and they want you to fill that room with tiles. Okay, you realize you cannot get a single tile which can occupy the whole room. Okay, so in that case, we would expect you to get a given size of a tile, which you can use so that if you combine many tiles, you cover the space. Okay, so it is the same reasoning here. You get it? So we usually look
Yes.
for the biggest size, and that size is usually our highest common factor, and it forms the sides of the square. And in this case, we've seen that our biggest side is 12. So it's going to be, the square is going to be 12 by 12 square, okay? And for you to get that size of the square, you have to multiply. That's why I'm multiplying 12 times 12. And it gives me 144 centimeters squared, okay? So the answer was supposed to
Yes.
be 144.
Yes, thank you. I've understood. Yes.
Joseph, I don't know if hands are on this question or a different question.
Yes, but unfortunately, our time is up. We are past time by 1, but I think we can use 10, at most 10 to
give them
go
a few
through.
minutes to ask, maybe.
Yes. Yes. Let's hear from them. Let's hear from Gladys first. Gladys, please unmute.
Teacher, I was asking that since of that question, they said okay, you said somewhere that if there is large, which means you're finding the greatest common factor. Now, if the question was finding, if here where there is equal squares as large as possible, they switched it and put equal squares as small as possible. Could you put the LCM?
Equal what? Equal squares?
If instead of saying equal squares as large as possible, they said equal squares as small as possible, then are we supposed to find the LCM?
No, I don't think they are going to set for you an application question of that kind. Because if they're talking of squares and then they say the smallest, that means you have to look for the smallest factor. Okay? And the smallest factor is not application of LCM. You get it?
Don't get it.
Okay.
Joseph, I don't know if you can clarify on what you told them.
I said earlier that questions of application, basically for highest common factor, will always have that highest kind of statement, okay? But for questions that want to test lowest common factor, lowest common multiple, will have least kind of, okay? Like the question, I think you did it, which had 3 balls. It had 3 balls that fall at a given interval of 8, 24, and then 32. Okay, and then they're asking you the length of time that elapses before they fall together again. So that is the least time you can obtain. And for that case, they are testing you whether you got the concept of lowest common multiple. Okay, so for lowest, you always have those least or lower statements. And then for highest common factor, we'll have highest or higher or something like that. Okay.
Okay, teacher. Thank you, teacher.
All right. Let's hear. Teacher, see you.
Okay, someone was asking about doing a question of changing from decimal to fraction. That's what I was trying to locate. You sent it in my inbox. And maybe in the meantime, you can be identifying a girl who did it to tell us how we can go about that.
Okay.
So, yeah.
Someone who did converting. Kirabo, let's hear from you.
Yes. When changing recurring numbers to common fractions, you have to first let the common fraction be an unknown letter. and now say let the fraction be x.
That's what you're saying?
No, the common fraction be x. Let the common fraction be x.
Okay. You can continue.
And then once you get x, you say x equals 1.34545 recurring. And then annex. X equals 1.34545 recurring. Since two numbers are being recurring, we get on the side of x we put 100, standing for the two numbers being 100 times 100x equals 100 times 1.34545 recurring. And then when we either we round off or not round off, like we cancel the zero, then we move the thingy 2 dots back, giving us 134.5454 recurring.
Do you realize that now you are having 54 recurring, yet the other part?
Yes, teacher, yes, I realize.
Okay,
And then we subtract 100x. 100x equals 134.545 recurring minus x equals 1.43545 recurring. Subtract them. Minus, we start, yes, 34545 recurring.
Let's say we add the 5 there.
Okay.
We leave it. So we subtract,
Yes, so here we get 99x equals 113.2. Then the rest are 0, so we leave them out. And then we get, yes, 9 out of x, 9x equals, no, not that, should not do that yet. Just leave it as 9x. 9x equals 1,332. 32, yes, put the 2. No, don't put the decimal point. Don't put it. We have removed it. So 32 out of, when you,
okay,
yes, out of 10, out of 10. Then after that, we multiply the 10 on both sides.
Okay, you cross multiply. In other words, there is an imaginary one here.
Yes. So 10 times yes equals 1,332. So then we divide 990 on both sides.
Joseph, I'm seeing some hands. I'm seeing some hands up.
Giving us 1. 1 remainder 342.
1
remainder 342 out of 990. Yes.
990.
And then when you divide them, like you get the 342 by 3. That's the way.
Which gives you what? 114?
Yes, and then the by 3 get 330. then when you divide them by 3 again, you get the top part, you get 19.
Get
19.
19.
Wait, no, 38. And then the last part, yes, you get 110 by 3.
10.
Yes.
That's all.
And then no, you reduce it again. 38 divided by 3. You get no, you divide by 2. I mean, then you get a 19 out of 55. Then that's your answer. It can't be divided anymore. That's your fraction, mixed fraction.
Okay. Joseph, can we
Yes.
have views?
Oh my God.
Okay, let's hear
Thank you.
from Emily.
Teacher, for me, I had a different way that I worked out the number.
Can you tell us?
I assumed the common number to be P, a common fraction. Then I said P is equal to 1.345345 recurring. Then I multiplied 10 on both sides of the equation and I got 10p equals to 13.4545 recurring.
Yes.
Then I had to get a third equation. So I multiplied 100 on both sides.
So did you call this equation 1? And this
Yes,
equation?
that was equation 1, equation 2, and then equation 3, I got 1,000 times P, the first equation.
Times the first equation, okay?
Yes. But 1,000, teacher.
1,000, eh?
Yes.
Why do you use 1,000?
Because I want to get from the first equation, I get 2 other equations from it.
Okay, and why did you first multiply by 10?
I multiplied by 10 so that after the decimal point, I can remain with only the recurring numbers.
Okay, so I guess it's important for your friends to understand that the recurring numbers are starting after 3, of which that one doesn't have a decimal behind it. Usually it's better if you are doing these numbers to first move the decimal to that point where the numbers start recurring from. So Emily, I think that's what Emily did. She first moved the decimal from where it is to here. She moved it to that point by first multiplying by 10 so that she can reach these numbers which are recurring of 45, 45. Eh? Okay, so you're saying we have
1,345.4545 recurring, and then I subtracted, equation 3 minus equation 2.
Okay. So you're having 1,000 P minus 10 P. Then on the other side, you're having 1, 3. Having 13 here. Okay. So what do you get?
I got 990p, which was equal to 1332.
So the numbers after this are zeros, which you can ignore.
Then I divided both sides by 990. And I divided until the lowest term.
Until the lowest term.
Yes.
So it goes with that. When you divide, you started with 2?
Yes.
Or 3? I don't know. What did you start with?
I started with 2.
What did you get on top?
On top I got 666.
And then down?
I got 495.
495. And then?
I divided by 3.
Gave you?
I got 222 out of 195.
195 or 165?
Sorry, 165. And then I divided by 11.
By 11?
Sorry, by 2.
By 2? 165 by 2, is it divisible?
Teacher,
so what did you, yes.
Maybe for the interest of time.
Okay.
We can ease their work.
Okay.
If they can get 133, if they have reached this point of dividing, making P the subject. Yes, they can get 1332 out of 990. Press it on their calcs, then they will get the answer very fast.
Yeah, on assumption that they know how to use the fraction button. These are S1s. Anyway,
yes.
They can work through the process. And Nicole, what was the final? Was 1 and what? Is Nicole still on?
I think I have lost. Okay. She has muted the mic.
Okay. But we expected them to get something of this kind.
Yes.
Okay.
Okay, we have Yvonne, maybe lastly.
Yeah, maybe Joseph, we can throw some comments on these 2 approaches. The 2 approaches are okay. I'm not saying that this first approach is not correct. It is okay. Only that it brings in an element of a decimal when you subtract, which you have to get out eventually. Yeah, but if you know what you're doing, you can still use it and you the same conclusion. Just like what Nicole is doing. She's first moving the decimal to avoid that challenge of having a decimal point after subtracting. So they will take you to the same conclusion. You just need to pick one which is easier for you. Yes, Joseph?
Yes, please. That is very right. Let's hear from Yvonne. Lastly, we have a number of questions, but for the interest of time, the girls need to rest. Let's have Yvonne last. Yvonne, please unmute.
Teacher, may you please explain that number that tells us to multiply these numbers that are in base 7?
Okay.
Joseph, this is my suggestion.
Yes, please.
It seems we still have many questions and some girls have already gone off. My suggestion is that we push these questions to Friday so that we can exhaust them.
Yes, please.
We might not do justice to some.
Yes, please.
Yeah, so girls,
So-
I guess let's push them to Friday. We shall start with those questions.